3D printing. And that's John Viscogliosi, not only a principal at Viscogliosi Brothers, but the CEO of one of the more dynamic companies, Centinel Spine. John?
Thanks, Robin, for the introduction. That will be hard to follow, and all of the presentations have been great so far. You know, one prevailing point that has come across in everybody's presentation is that data matters. Data is important, and clinical results are very, very important, as showed in Scott's poll of everyone of the importance of that. And I can tell you, in speaking with surgeons on a consistent, almost on a daily basis, is clinical results, long-term clinical results, and evidence is key. And that really falls into what I want to speak about with 3D printing. Is 3D, what really is 3D printing in comparison to current manufacturing standards? So 3D printing is actually a additive process, not a subtractive process. So historically, products have been made by removing material from bars or chunks of metal or plastic, where in 3D printing, what you're doing is actually building something up and not taking away from it. So this is a key point. This is something that I thought about a lot when I first really looked at 3D printing and getting involved. Is you are creating a metal or a plastic or the biologic is actually what you're doing. So it's very, very different, and I think it becomes incumbent on the companies to really understand that and make sure they understand what they're making and the actual raw materials that are being used, because it will vary greatly from what you're buying in your current specs. So currently manufacturing or in orthopedic implants, it's metal, it's different polymers, there's ceramics, and there's biologics. Where, you know, and those come in different forms, chunks, or pieces, and how do we then improve those characteristics? And I believe that 3D printing will allow us to do that, and science and data does matter here. So when you're creating the structure, you know, what are you looking for? You're looking for chemically inert products. You're looking for a bioactive action to be taking place. You're looking for something that is strong, has a high fatigue resilience, a low elastomeric modulus, so it interconnects good. You don't want things to be corrosive. So it needs, so when you're looking at creating this, creating your product, you really need to think about that, because corrosion does happen a lot in the body, as all of you orthopedic experts know. You also need good imaging characteristics in it for it to be relatively inexpensive. So why, one of the things I think about is, why are we now going back to metal when metal was in spine was a prevalence? Then everything went away from metal. Now we're coming back to metal. So have we learned that maybe some of the other materials work well, but not optimal? You know, you think about Wolff's Law and the compression, but what do you need for that compression to work? You need a strong scaffolding. You need something that interacts with the body to allow the cells to attach and proliferate. And when you look at that, it's important to understand that you're not just printing something or creating something with holes. You have to or should be taking, and you know, this is also for the doctors when they're looking at these technologies, to understand the structural scaffold that is built into the product. And we have seen, unfortunately, already some of the challenges or issues in 3D printing where you've had devices fail as they're being put in because they're not robust enough to take the insertion forces. And you've seen some products recall because of that. So you look at this interconnectivity of the pores, you look at the modulus of elasticity, but then you also need to build in structural integrity for that product. So as we've learned in the science, it is pore size and the degree of interconnection of those pore sizes. And if you look at a segment of trabecular bone, it's all different holes, all different sizes, but you need to look at that. And, you know, referring back to Chris's presentation about the Wild West in robotics, 3D printing is I would define as the wild west right now, where everybody's rushing to create something. And we all have to remember, at the end of the day, it's someone's mother, brother, sister, father, you know, that we're putting a product into. So the importance of the front end understanding of the metal that you're creating and what are those properties and how will that interact with the human tissue over a long period of time. Because remember, we're going for a fusion here with these products, or attachment to bone. So it's a long-term scenario and will be in the body for a long term. So it's not just, hey, I have a 3D printed product. There should be the science to back up of the design, the materials, and the understanding of what you're trying to achieve.
Terrific, John. So again, it all comes back to data, doesn't it?
Yep.
Wonderful, wonderful. That is a terrific presentation.